Record. So welcome everyone to the Aerospace and Defense Showcase. Pleasure having all of you today. This is actually our first 2-day showcase. Don't worry, it's not 2 full days. It's just 2 hours spread across each day for 2 days. So 4 hours total. And today's agenda is opening remarks, which I'm doing right now as we speak, the pitches. So we're going to start with Aerospace. That will go for about 50 minutes, 50, and then we will finish off with defense. What is Deep Tech Showcase and what is our vision? Really quickly, our goal is to bring more deep tech to market. And you might ask, how do we do that? And what the slide says is leveraging the power of community. What it is in actuality, and we'll go through it more in the slide deck, is these events that you guys are all participating in, which is fantastic, as well as working with both companies and stakeholders to find out what each party is looking for and trying to do some matchmaking along the way. And the overall goal, the overall thesis is our goal is to have more tech come to market, just because there's so much out there and there's so much that's usable, and the multiplier of what you're able to do now as opposed to 20, 30 years ago is insane. So we're trying to make sure that nothing falls between the cracks. And so, as I mentioned before, we have an ecosystem where we match startups with tech scouts as well as investors. And anchoring our events our events are the anchors where we have monthly events. This event is Aerospace and Defense. Next month, we're going to have an event focused on energy. And essentially, it's the startups are pitching. They get 5 minutes to pitch, and then 5 minutes of Q&A, and hopefully, as mentioned before, hopefully insightful Q&A, right? Give them some tips, give them some pointers. If you want to connect with them offline, that's fantastic. Go for it. Tell them, hey, we're going to connect after this. If not, that's fine too. But the goal of it is to get some insight and to get some guidance, and as well if there's some connection that can be made to make that connection. So the guided introductions are between the showcases. So after the showcase, there's a period of time where what we'll do is we'll do, as I mentioned before, matchmake. We will look for, hey, this company's developing systems for space, and right now NASA is looking for solutions for something similar to this. Hey, if we could make a connection to the director of corporate engagement in NASA, we'd be happy to do that and help that company get to where they need to be. So we'll usually send a couple profiles each month. If there's a mutual interest, we will make the introduction. And so this is the showcase calendar. As I briefly mentioned, this is the first 2-day event in Aerospace and Defense. You can see it right here. And next up is energy. And after that will be advanced materials. And then here's the team. As you can see, I'm front and center. But the rest of the team have really worked hard supporting and putting this together to make a really fantastic event. All right, so I'm going to go into a little bit about funding mechanisms of today, because especially with some of the uncertainties in the market, we felt it was relevant to give a couple minutes of background into what you can be doing, what you can be looking into, and how those things work. So the first, just to read off the slide, is angels, VCs, and corporate venture capital. And then one thing that we're going to talk a little about today is federal non-dilutive funding, which is R&D grants and R&D contracts. So there's a few programs that are open right now. The first one being AFWERX, which is the Air Force's fast funding mechanism. The National Science Foundation is also open, as well as the DOE and the EPA and the USDA. Just to give you a little bit of background on what an SBIR is, it's a Small Business Innovation and Research grant. Usually it's a 3-phased program. So phase 1 is anywhere between $50,000 and $275,000, which is a proof of concept. So that could be a blueprint. Phase 2 is $750,000 to $1.6 million. And that's for a working prototype. And phase 2B is usually some kind of unique match funding program or another kind of initiative from the agency awarding it. And phase 3 could be a sole source contract. Eligibility for this is to have under 500 employees. The R&D needs to be performed in the United States, and 51% of the ownership needs to be U.S. residents or individuals who hold a green card. National Science Foundation, SBIR. I'm not going to go too deep into it, but basically for phase one, it's $275,000. And generally, they're open to basically any technology. Their list of technology is pretty comprehensive of what they're looking for. They're kind of interesting because they're not using this mechanism in order to use the innovation for themselves. Rather, they just want to have more innovation. They benefit when companies are successful overall by getting the tax revenues from that. Next is the Department of Energy. There's quite a few topics, and the phase one is $200,000. You need a letter of intent before putting in the full proposal. Really interesting programs following on from them. AFWorks is, again, as I said before, it's the fast funding within 90 days. And then after that, what you're able to do is go for either a contract, but they have all these other kinds of programs like StratFi and TACFi, which we'll probably talk about later. But if you do a simple phase one, it's $75,000. A phase two is 1.25 million after that. Or you could skip that and do a direct to phase two. Just so everyone knows, some of the companies that we'll be presenting tonight are looking to find an MOU for a direct to phase two. So if you know of someone in the Air Force who is looking for that particular technology, feel free to put them in touch. Okay, and so we host an MOU club. What an MOU club is essentially an MOU is a memorandum of understanding. It's what's necessary to get a phase two from the Air Force. Basically, what it means is that an Air Force end user has to say, hey, I like that technology. And these are, I'm not going to walk through every single profile, but these are some of the companies that we're working with currently that are working towards the direct to phase two. So there's a lot of movement going on there. And I will be, if you guys would like, I can distribute this deck afterwards. And if you want to read the descriptions, feel free to. And again, happy to set up an introduction if relevant. All right. So today we are going to start with Aerospace. Who we have presenting first is Zephyr Computing, followed by Leo Labs, followed by Equatorial Space, followed by Undefined Technologies. And then for the defense session, we're going to have a meet the panel, which we're having right now for this session. So I cut it out of that slide. But after that is Acetos, Streamit, Profion, and Bebop Sensors. All right, so for today's panel, I'm going to quickly introduce the panel. When I say your name, quickly introduce yourself. And then also, I'd love to hear about within aerospace, because we're doing the aerospace panel now. What kind of technology do you think is going to be the most revolutionary, or what are you looking for or looking forward to seeing? So let's start with James Bolinger. If you want to just quickly introduce yourself and answer what interests you in the aerospace section, that'd be great.
Fantastic. Hi, everybody. 18-year Air Force veteran. I work in public relations and with innovation, as well as in the media. I currently at Vance Air Force Base, and I work with undergraduate pilot training for the Air Force. And what we are always looking for is anything to change or improve the way that we train the future pilots and how they're going to operate in a multi-domain battle space. So technology that helps them, things that help them learn, and anything that makes our planes fly better.
That's awesome. Next up, we have Warner Paredes.
How you doing? I'm Master Sergeant Paredes. I'm stationed at Robbins Air Force Base. I'm the 53rd Air Traffic Control Squadron Section Chief and Innovation Manager. So what's important to us is basically JADC2 and ABMS, so Air Battle Management System, and Joint All Communication for a technology that could connect the warfighter at the tactical and operational level that helps us communicate better, faster, and set up and break down mobile teams as fast as possible.
Perfect. Thank you so much. Next, we have Adam from Capital Innovators.
Hi, nice to meet everyone. So Capital Innovators, we're a Midwest-based venture capital firm. We have a pretty generalist focus on tech, and we invest at the seed to Series A stage. And within aerospace, a couple of interesting areas, certainly autonomous systems and sensors, but a lot of exciting developments. Thank you.
Awesome. Thank you so much. Next up, we have Bob Christopher from Diamond Edge Ventures.
Hi, yes, good morning, good afternoon, everybody. I'm with Diamond Edge Ventures. I'm with the venture capital arm of Mitsubishi Chemical Holdings. I've been here for 4 years. So before that, I was at Panasonic, heading up innovation. Nice to meet everybody here.
Awesome. Thank you. Thank you for being here. Next is Peter Ruiz from Invest Puerto Rico.
Good afternoon and good morning to a few of you. I'm Peter Reese with the Invest Puerto Rico. My role is business development director for the West Coast, for trying to attract companies to Puerto Rico. A lot of people don't know, but made in Puerto Rico is made in the U.S. So we're looking at we're mandated to help attract companies. At the same time, we help raise companies and connect them to capital through our platform called Impeller. So if you're looking to set up a new facility, or just kind of looking to set up R&D similar to what Honeywell and others like Pratt & Whitney and have done on the island, let us know. 50% of our graduates are recruited by the A&D industry. We have tons. We have average about 22,000 STEM graduates from the island a year. So feel free to reach out to me. I'm actually based in Los Angeles, but do travel out to Puerto Rico. So I'm available West Coast or East Coast. So.
Perfect. Awesome. Thank you, Peter. All right. Next up, we have Ted Fisher from Advanced CT.
Hi, good morning, good afternoon, everybody. Ted Fisher here, representing the ecosystem of aerospace and defense for the state of Connecticut. For the little state of Connecticut, we are an A&D powerhouse of manufacturing. I'm a degreed engineer and a business guy, and freshly back from the Farnborough Air Show, where we saw a number of new technologies that are interesting. Our charter is to expand and enhance the ecosystem of advanced manufacturing in the state of Connecticut. I'm particularly interested in companies that are looking at hydrogen technologies, as well as electrification of aircraft. Thank you for allowing me to be part of this opportunity.
Absolutely. Next up, we have Howard Thompson from Jessepro.
Hi, nice to be here and nice to join you guys. I've been working with Jessepro, which is a aluminum transport case manufacturer in Rockledge, Florida. And really what we've been trying to do in our tagline is innovate to protect, because we make one of the lightest, most rugged, smallest volume cases for today's military and commercial vendors. That's been one of my basic sales lines that I've been using since January when I joined them. I left the ecosystem in Ohio, where I have been working with NASA Glenn, the AFRL, a little bit of the Navy Crane facility, but I still maintain those contacts and relationships.
Awesome. Thank you so much. Next up, we have Cassandra Carruthers from Upheaval Investments.
Hey, all. Thanks for having me. Great to see you. Cassandra here from Upheaval. It is an early stage deep tech venture fund co-located in Chicago and San Francisco, where my primary base is. And I'm focused on early stage deep tech, fairly sector agnostic within that, and investing globally from pre-seed through Series B. Thank you.
Awesome. Thank you, Cassandra. And lastly, we have Mike Millard from Ecliptic Capital.
So my name is Mike Millard. I am the operating partner for Ecliptic Capital. We're pre-seed, seed in Series A. We're in Austin, Texas. We look for deep tech solutions that have lots of market adjacencies that can disrupt lagging markets. And we're raising our first fund, and right now we're hoping to get that closed in the next few months at about 100 million. And happy to be here. Thanks.
Awesome. Happy to have you. All right. And tomorrow we have some new faces, some old faces, but we are going to move forward from there for now. So without further ado, we're gonna start off with Zephyr Computing. Let me just open up the Zoom to be able to share. Jason, the floor is yours whenever you are ready.
All right. And thank you, Asher, for the intro, and thank you to Deep Tech Showcase for hosting this wonderful event. I'm excited today to tell you about Zephyr Computing Systems. We're a new startup founded about 18 months ago, and our mission is to democratize space computing and get the space industry ready for the next 1 million objects in space. I'm Jason Sarandolo. I'm one of the founders. The better part of 2 decades of experience, both in and out of the space industry. And one of the things that I've learned is that space computing today is limited by 1990s technology. Even flagship missions like the Mars Perseverance rover is still running on the same CPU that was at the core of those big colorful iMacs back in 1998. And that worked fine as long as you were building one satellite at a time and then operating it in geostationary orbit for 20 plus years. But now the industry is moving towards constellations of satellites in low Earth orbit, numbering in the hundreds or thousands of units on 3 to 5 year missions. So this has led to a massive increase in the amount of data and the requirements to process and downlink that data. And unfortunately, the current systems are not able to keep up with the demand. The solution to this is edge computing. So this is where you do the processing on board the satellite. So you downlink just the data products instead of all of the raw data. And at Zephyr Computing Systems, we're building a suite of developer-friendly tools across hardware, software, and firmware that'll power the next generation of computing in space. So at our core, we're providing an edge computing platform that'll support machine learning and artificial intelligence workloads to allow satellites to process data and make decisions on their own. The way that we do this is by using the latest and greatest terrestrial chips to provide an order of magnitude advantage for small sats. Of course, still need to deal with things like radiation, and that's where our proprietary hardening solutions come in that allow us to use these terrestrial chips in the harsh environment of space. Now I can take a look at our product lines. I could probably go on way too long on this slide, but we'll keep it brief today. So on the left there, you can see a photo of our first flight unit of Kestrel, getting ready for a demo mission in a few months. That's a general purpose data processing system. Kestrel is based on a GPU module. Hornet will be our next generation unit, and it'll be based on an AI-enabled chipset. Of course, you also need a way to store all this data. Current solutions in the space industry are large, heavy, and power intensive, and they don't have a whole lot of capacity. So for example, the James Webb Space Telescope that is giving us all those beautiful images of the cosmos, it only has a total of about 68 gigabytes of storage on board. So compare that to the terabytes that you have on an SSD on your laptop. Unfortunately, those SSDs don't do well in the space environment. So what we're doing is taking the best of both worlds to deliver a high capacity, rad tolerant SSD. And of course, you also need a way to get all that information down to the ground. So we also have plans for a high bandwidth software defined radio. And the reason that we do all this is to enable our customers to maintain their competitive edge in the market. So an example of this from the other side was when I was working at Loft Orbital. I was the only full-time electrical engineer there, and I was tasked with finding an edge computing solution for our hosted payload platform. And I did a survey of the market, and unfortunately wasn't able to find anything that met the performance that I knew was possible. Now that I'm at Zephyr Computing Systems, we're going to be building those units and providing an easy-to-use, ready-to-go solution to our customers that takes advantage of the years of knowledge of our team. And that'll allow our customers to focus on what they do best. So speaking of the team, here are our founders. All of us have previous experience in the space industry, and in fact, all of us worked together at Capella Space. I remember about 2 weeks or so after I started, the deal fell through with the vendor that was going to provide the radio to Capella. And the rest of the company kind of looked around, looked at us, and asked, is this something that we can do internally? And 6 months later, we had hardware on the bench, undergoing testing and getting ready for flight. And that's the same design that Capella uses to this day for their synthetic aperture radar sensing, onboard processing, and high data rate downlink. Look at our roadmap. So last year, like I said, we were founded. We also won NASA's Entrepreneurs Challenge, which gave us a little bit of money to get started. We also raised a $500,000 pre-seed round that allowed us to build out our core team and technology. This year, we're focused on our first customers and our sales pipeline, and we're also getting to work on our first NASA SBIR contract. Next year, we're excited to launch our first demo mission, and that'll be quickly followed by customer flights, and that should set us up well for a Series A raise at the end of next year. After that, we're looking towards expanding our portfolio into other satellite components, further hardening our existing designs for missions up to MEO, GEO, and cislunar space. And then by the end of the decade, we'll have our own fully custom silicon chips and getting ready for interplanetary missions to Mars and beyond. And this all starts with our seed round. So we're looking for a $5 million seed round to unlock our first flight, secure our early customer contracts, and grow the team out. And of course, we'll also be pursuing non-dilutive government funding as well. And with that, I'll turn it over to questions.
Absolutely awesome. Thank you so much, Jason. So how we'll do questions is if you want to raise your hand within the Zoom, what we'll do is first come, first serve in terms of whoever raises their hand first gets to ask the first question. Yeah, and let's open up the floor. Cassandra, go ahead.
Thanks. Great presentation. Curious what your business model will look like, maybe in the near term and in the future. And then a separate thought, it doesn't have to be them specifically, but wondering how you'd play in the space with someone like Privateer. Would you enable those businesses, compete with them, or something in between? Thank you.
Okay, yeah, in terms of our business model, right now we're focused on direct sales with support contracts. And then with these constellations with such a short lifetime, that essentially winds up being a recurring revenue model.
Of the chips themselves, right?
No, of the complete systems.
Okay.
So right now we're delivering a complete system. So it's an aluminum box with connectors. You just plug it in and go. Our next generation unit will be based on a system on module design. So we'll be able to sell not only a complete system, but also just the core technology. And that's useful for customers that might have a more integrated design and don't want to have too many boxes stacking up. And then for your other question, unfortunately, I'm not super familiar with Privateer. But yeah, in general, we're looking at enabling a lot of these constellations. I'd say our top 3 customer classes are Earth observation companies, satellite to satellite communication companies, and then satellite inspection and servicing companies.
Perfect. Awesome.
Jason, this is Bob Christopher. A question for you. Do you have this? I'm curious about the thermal dynamics of your box, and you're running a GPU, which can produce a lot of heat. What are you doing anything around heat sinks and thermal dynamics in your future box, future version? And how do you manage that? This question.
Yeah, we have a variety of solutions that we're looking at. So right now, we're fairly low power. Our complete system running full out is 25 watts, which you can handle with heat straps and just standard conduction techniques. But for future designs that are going to be higher power, 60, 100 watts, we're looking at working with a company that makes space grade heat pipes using a water copper solution. As well as custom machine parts, not only out of aluminum, but also other alloys, especially like an aluminum carbon alloy that'll sort of like a graphite heat spreader. So that'll allow us to spread the heat out and then get it out to the chassis.
Great, thank you.
Perfect. I saw a question from Mike. And Mike, do you still have a question?
Yeah, mine was just a little bit kind of similar to Cassandra, I'd like to know more about the business model and the sales cycle and understanding what partners you might be having to work with.
Mhm. Yeah, so the sales cycles are trending with the industry. They're getting faster and faster. So it used to be several years to get on a mission. We're seeing that close to as short as 6 months now. And then I'm sorry, what was the second part of your question?
It's just understanding which partners you might actually want to be working with to help you
Right.
with your business.
Yeah, so our top two partners right now is Endurosat and Orbital Transports. They're providing the hosted payload service for our initial demo flights. With those flights, though, we're also viewing them not only just as a technical demonstration mission, but also as a sales demonstration mission. And now that we've gone through all the work of integrating our system with their platform, for future missions that require onboard computing, we're essentially a drop-in option for these companies to then turn around and provide edge computing as an value-add service to their customers.
Thanks.
Just a quick follow-up question, Jason. You're developing, I guess, right now using a GPU, but you're developing sound like a full stack solution with, like, I guess, an ASIC chip with AI built into it, and that's going to be also lower power, perhaps. I didn't quite.
Yeah, it'll be more power efficient, about 5 times more efficient in terms of performance per watt. And that's specifically in terms of frames per second per unit energy.
And is that being developed by a partner company, or is that being developed by your company?
No, we're not developing the chips just yet. That's tens of millions of dollars investment. So we'll be sourcing those chips from another company.
Yeah, just curious because I'm familiar with a couple of companies that are doing that in Israel that are doing really nice AI ASIC based chips. I came from the robot industry years ago, so I've been following. It is an area. The edge computing is obviously big for a lot of things, including autonomous cars and aircraft and all sorts of applications. So yeah, I'm just really curious about how you're approaching your main compute challenge, if you will. It's always kind of gets down to the brass tacks of how you design something, right? And your architecture, and then your decisions are made with materials and everything else. So it's fascinating. I was also just kind of wondering, it doesn't sound like you're in that space. I mean, no pun intended, but the using communication systems, it doesn't sound like you're using a lot of data to send to Earth. So there's not a big issue with transport, but there's a lot of, I guess my question is about, are you working with any type of data transport layer that you have to tweak and optimize for your system? Because we spend time talking to people about GAN systems for satellite communication for various applications. And I just didn't know if you got into that level of detail with your system.
Yeah, we're not quite that far down the stack right now in terms of like getting into antennas or amplifiers. Even for our software-defined radio, we'll be providing that more as like a baseband radio, maybe with an RF adapter for frequency conversion to the K bands. And then in terms of the network protocol, our units just use standard Ethernet. So our next generation units will support, I think, up to 4 units of 100 gigabit Ethernet, typically done over fiber. So it's a 100 G base SR4 to be technical. We really like using standard protocols and standard interfaces. It just makes our integration a lot easier.
Thank you.
Perfect. Jason, just so you know, there's a question in the Q&A, and I think there might even be another question in the chat. So feel free to check those out. Don't sign off until you've answered those two, at least. And then, thank you so much, Jason. That was a fantastic presentation.
Thank you.
For the next presenting company, we have Leo Labs, and the controls. Feel free to. Oh, by the way, Jason, don't forget to leave your email in the chat or some kind of contact info, a LinkedIn link even, so they could reach out to you. Okay, next up we have Leo Labs. Presenting for Leo Labs, we have Victor Gardner. The floor is yours.
All right, thank you, Asher. My name is Vic, and I am the acting president and technical director of our Leo Labs federal subsidiary. So Leo Labs is a post-Series B company, startup, founded in 2016 in Menlo Park, California. We have a pretty robust commercial business servicing customers such as SpaceX, Planet, Black Sky, and Rocket Lab. And so I am charged with bringing our same technologies into the defense market. So I was going to share some defense products with you. We own and operate 6 radars around the globe, and these are phased array radars that track objects in low Earth orbit and provide space domain awareness and space flight safety alerting to our customers. What we want to do is utilize these same radars to build products for users such as the Space Force, Space Command, and intelligence community. What I'm showing you today is kind of a roadmap of some of these defense products. We have released earlier this year a product to track high interest objects, basically threats out of adversarial nations around the world. So providing constant monitoring of these threats in low Earth orbit, maneuver detection and characterization, and patterning of life of their activities. We also have a new product in the works for providing automated indications and warnings of allied assets. And so this is high value assets from allied nations such as the US, Israel, the UK, Australia, etc., where we're monitoring threats. We're letting the allied nations know when something might be in its neighborhood, have an opportunity to engage. So essentially, preparing for space as a warfighting domain, and then finally, later this year, we hope to add more automation to our non-cooperative launch tracking. So I mentioned SpaceX and Rocket Lab as a customer of ours. Right now, we do cooperative launch tracking for both of them. What we would like to do in the defense market is do non-cooperative launch tracking. So tracking adversarial launches out of China, Russia, other places when we don't have a queue. So there's a little more tech required for that, a little more automation we'd like to do. And so that's another product we have in development. So a little deeper dive into our high interest object tracking. These are some of the screenshots from the minimum viable product we released last quarter, where we're providing service level agreements of how often we're able to track each of those threats, some automated maneuver detection to alert defense operators and space guardians of when these threats have maneuvered and changed location, and then finally some stability monitoring of whether this threat is still active and operational. Product in development currently for a neighborhood watch with automated indications and warnings of the threat activity. A little more focused on the visualization here. So this is a a Leo Labs homegrown visualization where we're depicting the battle space and how an adversary is interacting with or engaging allied high-value assets. And then finally, a little more on the non-cooperative launch tracking I mentioned. In the bottom right, you see an example of some of the launch tracking we have done for SpaceX. And so our differentiators here are that we're using phased array radars that not only take range, azimuth, and elevation measurements, but also a very precise Doppler measurement. And that is what allows us to quickly separate each payload, identify each payload, and give a solution to the operator of where every payload on the launch is within 24 hours. So that's a discriminator over the free U.S. government service, which is really our only competitor at this juncture. And so this is the differentiator that in the cooperative market has brought us a lot of business. And so now we'd like to do the same for non-cooperative, when we can identify how many payloads are on an adversary launch and determine quickly and automatically what orbits they're going into. So with that being said, I'm looking for help to help bring this into the defense market, get connected with users, get connected with buyers. And with that, I'll take any questions. Thank you.
Awesome. Thank you so much, Vic. All right, opening up the floor. As we said earlier, first come, first serve in terms of raising the hand. All right, Mike, go ahead.
Thanks, Victor. That was great. I'd like to know more about who are you targeting? Like, who would get the most benefit out of this when you look at your customer set, within the U.S. and possibly other places?
Thank you. I believe first and foremost that the National Space Defense Center is charged with, fighting a future space war. I also think that some of the U.S. government owner operators like the National Reconnaissance Office or Space Operations Command would be our targets for some of the high value asset monitoring and automated indications and warnings products.
Other places around, what I'm curious is, does your solution create a natural conflict between different agencies that are monitoring different, satellites and what's happening? Does that make sense?
It does. I hope not. For example, I believe it would be U.S. Space Command in charge of monitoring non-cooperative launches. And so that's who we would target with that product. And then I've been solely focused on the U.S. market so far in this pitch, but I do believe this translates to each of the space commands, worldwide, over in Australia or the UK or France, Canada, etc.
Okay, thank you.
Thank you.
Go ahead, Ian.
Okay, sorry, it took me a second. So I guess my biggest question for you is, you'd mentioned UK and France. So do you have any relationships there, and do you have any current relationships with NRO Spacecom? Because last I checked, I thought Leo Labs was already working a couple things with them.
Let's see. I'm probably not the right person to kind of disclose our international relationships, but in the US, our current contracts are with the National Oceanographic and Atmospheric Agency, NOAA. We're expecting a sole source from the Department of Commerce for their space traffic management efforts. And we have one intelligence community customer. We do not currently have US Space Command or the Space Force as a customer.
Okay, yeah, let me know if, and if you're not at liberty to talk about it, that's fine. Let me know though, we can contact off or talk offline if you're looking to connect with the French, UK, German Space Forces, those.
That would be excellent. Yeah, thank you. Let me chat my email if that's easiest.
Yeah, perfect.
Awesome. Excellent. Thank you, Victor. Unless there's any last question, we have time for one more question. If someone has a last one, feel free. Otherwise, we're going to keep the cadence. All right, James, go right ahead.
Hold on. Sorry about that. I actually was trying to click on something over at the chat and I accidentally hit raise hand. Sorry about that. I did not have a question because I don't have any Space Force connections.
Okay, no worries. Perfect. All right. Thank you so much, Victor. It was a pleasure having you. Feel free to again drop your contact info. Keep your eye on the chat just in case there's a few last questions that you might have. Then next up, we have Equatorial Space. And the floor is yours whenever you're ready.
All right. Hello, everybody. How's everyone doing today? Just let me screen share. And all right, can you guys see my slides?
Yeah, we can see it, but now it's presentation mode. Perfect.
All right. All good. All righty, thanks a lot. Hello, everybody. Great to be here. So first of all, I think, I speak on behalf of my entire generation that, we feel a little shortchanged with the lack of progress with space tech compared to what we were expecting to happen by now. By the time we were, in our 30s, which I personally am right now, we were supposed to already have presence on Mars and hotels in orbits. And reality, well, is a far cry from that. And that is because, well, propulsion technologies didn't really change fundamentally in the last several decades. In fact, human beings and cargo are still strapped onto what essentially are flying bombs, and that makes spaceflight inherently dangerous and what we can do with spaceflight inherently limited. Contemporary rockets are still fundamentally dangerous. They are still flying bombs. They have a TNT equivalent. They are also still pretty expensive because there's only so much you can reduce the cost of a liquid-propelled rocket system. An increasing concern is also their level of pollution, especially that launch capacity is slated to be quadrupled in the next 10 years or so, and that's only the next 10 years. And those things are essentially what are, all of those factors are essentially reducing what we can do in space as a species. This is the problem that we have set off to resolve as a company, and it's we have sorry about that. Essentially, what we have done is create rockets of tomorrow. All right, rockets which are inherently safe, rockets which are non-polluting, and rockets which are very low cost. Right, and how do we do that? Is by taking hybrid rocket propulsion. I will presume for the purpose of this presentation that you guys have no prior exposure to hybrids. So let me explain a little more about that. If you take a tube and fill it with an explosive, you essentially get a solid rocket motor. They are ready for flight at a moment's notice, but they cannot be controlled, they cannot be shut down if something's going wrong, and they cannot be throttled in flight conditions. So they are really only useful for things like tactical applications or for boost phase. Majority of commercial companies, of course, use liquid propulsion. Liquids are very complicated. The complexity typically comes from the oxidizer and fuel delivery system. And as a result, they have a fairly high failure rate, especially among newer entrants into this field. What we work with is known as hybrids, and hybrids are interesting because they use a combination of liquid oxidizer and solid fuel, right? So the solid fuel in this context is actually non-explosive by itself because it's not pre-mixed with oxidizer, right? The two things are separated into two states of matter. Accidental mixing is simply not possible in this configuration. They can also be throttled and shut down, which gives you the very same functionality as liquid rocket systems at a fraction of the cost. Hybrids are remarkably simple and mass production friendly. To give you a ballpark, they cost around 25% of what a liquid of similar performance would cost. And with a very straightforward system, they can also you can also implement things like restartability, which is of interest not just for space launch but also for some tactical applications. I'll get to that shortly. Just to illustrate to you how safe hybrids are compared to liquids and solids, well, this is an example from the early 90s from the company called AMROC, American Rocket Company. Some of you might still be familiar with that one. Hybrids are energetic. Of course, they have to be, because if you want to have any kind of combustion, you need to use energetics, but at the same time, it doesn't actually blow up. In the context of our longer-term aspiration as a company, which is to support human spaceflight, hybrids offer you minutes of reaction time. They allow you to evacuate the crew, for instance, or to even try to put out the fire. That's something you simply cannot do with a split-second detonation that creates an actual overpressure event. So hybrids don't have that problem. In fact, NASA was considering using hybrids for as a replacement for the Space Shuttle SRBs because they can be shut down if something goes wrong. But the reality was that the solid fuels available back then simply weren't good enough. Hybrids were always limited by the performance of the solid fuel, and that's why they were typically relegated to your undergraduate propulsion course if you were, in college, but not something that you would typically look for when you wanted to get a viable option for space launch, right? And that boils down really to the solid fuel performance. Rubbers such as HTPB require plenty of heat input to actually melt away, if not pre-mixed with oxidizer. And waxes such as paraffin wax are not structurally stable in flight conditions, suffer from mass ejections, and as a result, you can experience 10, 15, 20% of your propellant just being lost to mass ejections and afterburning, as you can see on the example here on the left. So the two big problems were always essentially low regression rates and/or poor structural integrity of the solid fuel. And this is exactly what we have resolved with our proprietary IP. We've got a much higher performance compared to HTPB, and we are actually structurally stable. We can also mix it with a lot of aluminum powder. That's one thing I can disclose, and that gives us higher density compared to anything else. So our launch vehicles, when used with properly stored and refrigerated nitrous oxide, are essentially completely inert. With some reusability, we are confident in reducing the cost per kilogram based on a particular segment of the market by up to 90%. And we also produce only around 30% of the greenhouse gases compared to traditional rocket systems, like Carolux.
Good morning.
Yeah, alrighty, so wrapping this up. Well, in the long term, we plan to reduce the cost per kilogram to under $1,000 with this technology as we scale it up and enable not just satellite launch, but also things like space tourism, space manufacturing, and space mining. And there's also a bunch of things that you can do on the defense side. Let me just speed this up a little bit. Our suborbital system would make a very viable product for hypersonic boost and target practice. And hybrids can also be used in tactical applications in products such as high-speed torpedoes, jet-assisted takeoff systems, and air-to-air missiles that you can actually throttle and therefore accelerate rapidly in the vicinity of the target. Who are we? Aside from myself, we've got Jamie Anderson, who is our CTO. He spent 30 years working with hybrids, and Marcelo Martinez worked with ballistic missiles, UAVs, and sounding rockets for 40 years in Argentina, US, and Europe. Praveen is my co-founder, who came from material science background. Thanks a lot. I overran. I'm sorry about that, and I'm looking forward to your questions.
All good, all good. All right. As mentioned before, thank you so much, Simon. As mentioned before, raise your hand and we'll get to them in order. All right, Howard, go ahead.
As you're talking, I'm literally looking at my email that blurbed in, and they were talking about an X-bow systems, X as in, and then the bow, and how their successful rocket launches, and then their first stage burn and payload stage separation. Is this similar to the stuff that you might be talking about, or are you talking about like a different application in the kind of the launch system itself?
Yeah, so as a company, we are really providing the propulsion products, but our own aspiration is also to build our own launch vehicles. What I can, I'm not at liberty of disclosing the names of the two prospective clients that we are working with, but we are in fact pursuing contracts for development of customized rocket engines. Building a main propulsion system for a launcher that's based on a hybrid system would require a complete redesign of the entire rocket, which is a commitment that a launch service provider may or may not be willing to make. But hybrids would at the same time make a fantastic replacement to solid rocket boosters and augment performance without introducing an additional hazard on a pad. Not sure if that answers your question properly. Okay, awesome.
Perfect. And then there's one question in the Q&A, which I'll just read out here. How did you solve the hybrid problem? Novel fuel composition, what is the IP around it?
Yeah, so it's a patent pending fuel composition. It's a chemical formulation. All I can disclose is that it's a combination of low molar mass polymers. They are very, they are not difficult to source. They are in fact quite straightforward to source and also to mix together once you have the formulation in place. So that makes it very mass production friendly. And we're currently drafting the patent application for it.
Perfect. Perfect. Absolutely. Thank you so much, Simon. Simon, feel free to leave your contact information
Absolutely.
in the chat. And I think there's actually one more question in the chat as we speak. So definitely take a look there and feel free to answer your network there.
Alrighty, I'll just answer Peter's question real quick. Yeah, so the company was actually formed in Singapore, which really is the basis for the name, but we are now based here in States. And we do plan to implement sea launch capability once we build our own launch vehicles to specifically capture the ability. I mean, we are aware that there is a pent-up demand for equatorial low Earth orbit access, and currently nobody is offering that. There is only some movement towards that from Kourou right now. So that was one of our tenets right from the start. So hopefully that answers it.
Perfect. Perfect. Absolutely. All right. Thank you so much, Simon.
Thanks
Next up, we have Undefined Technologies. Presenting for Undefined will be Thomas. Thomas, feel free to share your screen when you're ready.
Excellent. Thank you, Asher. Can everybody see my screen?
Yep. See it
Okay.
perfectly.
Okay, very good. All right. Okay. So, as Asher mentioned, my name is Thomas Privanik. I'm the founder and CEO of Undefined Technologies. We're an early stage startup located in Doral, Florida, and we're developing selling propulsion technologies for the last mile cargo delivery sector. As you know, all the big name companies such as Amazon, Walmart, and Walgreens are moving forward with having drones deliver their goods in urban areas. Now, they have to go through a certification process. And within that certification process, noise is a big item. It's an item that has not been solved yet, and they have to get it in order to, they have to get it certified in order to become viable. Just to give you an idea of how loud current drones are, they generate between 76 to 95 decibels of noise. And it's not only the amount of noise they generate, but the pitch generated by these fast rotating propellers. These propellers generate a very specific pitch, which has proven to have negative psychoacoustical properties or consequences for humans and animals. The noise is so important that the FAA, that last year the FAA issued a notice of proposed rulemaking, and it's the first time that the FAA has issued such a notice for drones. And within these documents are very specific standards that now these crafts have to overcome in order to become certified. An alternative to fast rotating propellers is solid-state propulsion. Solid-state propulsion has been used for space applications for decades, in which a fluid is ionized and then it's rapidly accelerated in order to generate propulsion. Undefined Technologies owns exclusive license rights to the ion booster technology, which is a discovery that I made during my PhD at the University of Miami, which makes it possible to use ion propulsion in atmospheric conditions. And it carries a lot of benefits. It can be used to generate propulsion silently and also to carry out stealth missions. With the ion booster technology was integrated into a craft called Silent Ventus. Silent Ventus is a craft that measures 5 feet by 5 feet, uses ion propulsion to generate thrust in the vertical direction, and a vector thrustering device to generate control and navigations. Now, this Silent Ventus craft has gone through 2 test flights, one of which lasted 30 seconds. The second one lasted 2.5 minutes. And this Friday, we're gonna be meeting our milestone 2 for a total flight time of 5 minutes. Our projections are to get to 50 minutes of flight and 70 decibels of noise, which based on our market research, including feedback received from UPS, we need to be within 50 minutes of flight and carry 2 pounds of cargo. At that point, we become competitive with the current technology out there. This is the timeline and a couple of pictures of our prototype crafts. The one on the left is the one that flew for 30 seconds. The one on the right is the one that flew for 2.5 minutes. And behind me, you can see the guys working in the one that we're gonna be flying Friday. As far as our market share goes, one of the things that I want you to take away from this is the defense, enterprise, and logistics sector. Right now, the defense is where the most of the funding is taking place, and then the enterprise and logistics will start picking up. So our strategy aligns with that approach to start more in the government sector and defense sector, and then mature the technology and transfer and then transfer over the commercial sector. We're in talks with several potential customers, including Amazon, UPS, and DroneUp. As we move into the next phase of milestones, these negotiations will turn more into will materialize. Our competition landscape. We have several companies that are offering or will be offering drone delivery services, all of which use rotary propulsion technology. We're the only ones who offer solid propulsion technology. In our business model is our strategy is to partner up with a drone manufacturer in order to manufacture the drones using their capabilities in our license and technology. As far as funding goes, we have completed our seed round. We closed shy of $1 million, and we're raising $3 million, out of which 1.3 we want to raise, or we project to raise from government funding. We have an invitation by the Air Force to apply for a direct to phase 2 award, for which we need to solidify the MOU. As far as our team goes, I put together a team of very diverse and talented individuals, each one with a specific task and attributes. And we also have our board of directors who are not only investors, but are well-seasoned venture capitalists who are helping us in getting our funding milestones met. And that's all I have. Feel free to ask me any questions or reach me out to my cell phone or email, and I'm gonna place my my contact info on the chat as well.
Perfect, awesome. Thank you so much, Thomas. It looks like Mike has a question.
Yeah, Thomas. Yeah, can you talk a little bit more about your license with the University of Miami and what that entails?
Yes. So while I was doing my PhD at University of Miami, I made a discovery, and the University of Miami owns the discovery, but I am the inventor, which means that I own a third of it. So we have a license agreement in place as well with Undefined Technologies. So we are the exclusive licensees of that technology from them. So nobody else can use it but us.
Right. Is it an equity stake, or is it just a licensing agreement where you have a revenue?
There is an equity stake. Yeah, there's an equity stake with them. They own about 5% of our company, which is non-dilutable up to a certain point. And there's a running royalty on that, which was negotiated to be sure it was staggered and it was reasonable.
Okay, thank you.
Awesome. We have time for 1 or 2 more questions, and we'll give it a couple seconds before we continue on.
I have a question. Good presentation, and congratulations on your invention. It's very very impressive. I looked at your business model. It sounds like you're going to be OEM licensing to drone manufacturers. But at the same time, you're also listing drone manufacturers as your competitors. So is your revenue model based on a service model, or is it based on a licensing model that you sell your technology to other companies?
It's based on a licenses model. Now, you're correct that right now the competitors and potential customers, they overlap to some degree. But as the technology matures and we are able to engage the strategic partners that we want to engage, that's gonna go away. But as it sits, they are our competitors.
So right now you're just doing an evolution. So stage one is to license, work with these companies, but eventually you want to become your own service provider. Is that correct?
Well, we won't be the service provider. We will create a partnership with a drone manufacturer, and
Okay.
then they'll speed up the revenue generating process as opposed to starting from zero and creating a warehouse where we're going to be putting together drones.
Okay, thank you.
Perfect. Awesome. Awesome. Thank you so much, Thomas. Feel free to leave your information in the chat. And yeah, and thank you so much. That was a great presentation. Next up, we have not a pitch, but we're switching over to the defense section of today's event. And so real quickly, what I want to do is I want to run through the current panel we have one more time. And just instead, I'm going to change my question from what interests you within aerospace? What are you looking for within aerospace? This time it's going to be, what are you interested in defense? And full disclosure, before anyone answers, the defense session we have coming up is very varied. So there's quite a few different solutions that are in a lot of different areas, which is really great. I like some good variation. So just to let you know, if it's not, something classically defense, it's fine if that's what you're interested in within the defense field. So feel free to answer how you want. Let's give the floor to James Bolinger again.
Hey, Asher, you're going to say that what question one more time? You cut out right in the middle of it.
Ooh, sorry about that. Yeah. So the question is what interests you in terms of defense? I know we covered aerospace, but now we're in the defense section. I want to hear the defense interests for you or for your organization, or what you're interested in personally.
All right. Thank you, sir. All right. So once again, James Bolinger, Vance Air Force Base, and I work with undergraduate pilot training for the Air Force. From the defense side, project management is always an interesting portion of this, but also any emerging technology that can once again help with pilot training is always of an interest. So thank you.
Perfect. Thank you so much. All right, next up is Warner. If he's still with us, not sure if he had to jump or not. Nope. Let's continue on. Next up is Adam from Capital Innovators. Adam, the floor is yours.
Hi, yeah, we're Capital Innovators. We invest at the pre-seed to Series A stage. We're tech generalists, and within defense, one area of interest to us has been geospatial data. Thanks.
Awesome, perfect. Bob, you're up. Bob Christopher from Diamond Adventures.
Hi, nice to be everyone again. So I'm with Mitsubishi Chemical Holdings. I'm on the venture capital side. So as our company, we're involved in a lot of material developments for space and satellite systems. So I'm really just looking for opportunities to understand and learn around new technologies for satellite systems and how we can maybe participate. Thank you.
Absolutely. All right, Peter, go right ahead. The floor is yours.
Hear me? So we're looking for more low Earth orbit capabilities, or people in that sector. Anything in the national security, but since we're in the Caribbean, we're part of the US, but we're in the Caribbean, just looking to be an expert or a regional hub for the expertise in that area. Anyone in that southern US, southeastern US part.
Perfect. Thank you, Peter. Oh, and okay, that's perfect. Ted Fisher from Advanced CT, you're up.
Yeah, thanks. Connecticut manufactures submarines, jet engines, and helicopters, and the defense industry is very robust in our state. I'm interested in all new technologies that can be somehow connected with or associated with our OEMs. We have a number of companies that are looking to expand their technical offerings for deployable vehicles. This is stuff that gets dropped out of aircraft to potentially do automated stuff on the ground. That would be interesting for me. And again, electrification is a big topic in our ecosystem. So that's what I'm interested in.
Perfect, perfect. And there's actually a company that is doing something similar to what you mentioned that's going to be presenting. So we'll see what you think of them. Next up, we got Howard Thompson from Jessepro.
Hey, Ted, we make a aluminum case that you could drop out of a helicopter and it doesn't crack, bend, or dent. So there you go. We'll help you in that regards.
Let's connect.
And then the only thing that, I'll add to that is it's amazing from a sustainability factor how challenging it is for me to talk to defense guys about aluminum being lighter and more rugged than plastic. And I'll leave it at that.
All right. Next up, we have Cassandra Carruthers from Upheaval Ventures.
Thanks, Asher. I suppose not too different from some of the interests here. When we look at, or my interest in defense lies primarily in technologies or concepts and innovation that can enhance national security broadly. So I feel like some sectors I end up spending time in there are aerospace, robotics, some cybersecurity, things around critical infrastructure, recently more on the autonomy side. So I end up looking quite a bit at dual use, if anything, and less specific to or solely defense, primarily because our fund has been, we look for kind of that definitely dual use, like it must also have a commercial application.
Sure, absolutely. Thank you so much, Cassandra. And then lastly, we have Mike Millard.
I'm with Ecliptic Capital. We like deep tech solutions, and right now we're looking at a lot of cybersecurity and national defense in terms of from a software and cyber attacks. We're noticing that is on the rise. That's a big focus for what we're looking at. So looking forward to the session. Thanks.
Absolutely. Thank you for being here. All right. So with that, we've introduced our panel. Now we shall kick it off with presenting Acetas. And I believe that Tom is going to be presenting for us. And the screen share you should be able to share your own screen whenever you're ready, Tom.
Okay, 1 second, please. All right, thanks for your patience. I'm not used to Zoom here. Okay, can you see my slide?
Yeah, I can see it, and it's in presenter mode, so it's perfect.
All right, perfect. Well, good afternoon. Thank you for your time, and I appreciate it. On behalf of Acetas, I'd like to share what it is, what we're working on, some innovations that we have. And so the topic is around equipment maintenance, asset maintenance. So physical equipment, whether they be weapon systems or all the way down to a simple hand tool. So just as a background or context, many companies, a significant portion of their balance sheet is for physical equipment, power, plants, property, and equipment, PP&E, if you look at the balance sheet. So you can see the spread here between oil and gas to defense to technology companies like Microsoft. Even though high-tech sectors, we don't think they have a lot of equipment, but they do. They have plants, they have equipment, server farms, and so on. And the opportunity here is to come up with a better way to manage assets. And let me cite 2 examples why this is so important and critically needed. So first, emergency generators installed at military bases installations. A DoD report concluded that 1 out of every 2 generators will fail after 48 hours of runtime. That's 1 out of every 2. Okay, second data point. Scheduled maintenance for aircraft carriers and submarines. The Department of the Navy spends approximately $500 million a year to maintain carriers and submarines. This is scheduled maintenance. Unfortunately, 75% of the maintenance is done anywhere between 6 months to 9 months late. So 75% of maintenance is done late. So this is a real challenge, and it's not because of the lack of procedures, human or capital resources, or operational needs. These are very critical infrastructures, equipment that are needed. And so what we'd like to do is share our journey of how we are arriving at a better solution. So our solution involves 4 key components. First, helping companies to know what it is that they own. By design, make, model, serial number, down to bill of material, everything that is essential to think about maintenance and upkeep. Second, we also fold in signals, which include anything from IoT sensors to human insights into how equipment is running. So think inspections, visual inspections, checklists, that sort of thing. Third, we also support digital workflows that automate work, whereas whether operational SOPs or Air Force procedures or anything like that, the idea is to integrate the workflow into the digital ecosystem so that everything is very seamless. Things from communication to completing checklists to submitting the data for review and QA, and then also pushing the data into databases to support machine learning and other modeling. And then lastly, what do companies do with all these insights? There's a lot of excitement around predictive maintenance, but unfortunately, that's very limited to a few things, such as airframes and weapon systems. Our proposal is that the defense sector, along with other sectors, can implement our approach to a broad class of equipment, anything from simple equipment all the way to weapon systems. And I'll give you two examples of our work. First, just as a context, in the state of Colorado, there are approximately 120,000 oil wells, and each oil well has to be inspected using a series of regulatory forms, 46 in all, for just one agency. And these forms range from a one-time inspection to monthly to annual inspections. In this example of Form 17, we have digitized the form to be scannable using a QR code, and the form pulls up on the right-hand side. For companies, we can also include proprietary well data into the form so that staff and contractors can go out to the field in an offline capability, conduct the work, the data comes back, is checked, approved, and then gets electronically submitted to the regulators, saving the company and the regulators time in field transcription, trying to figure out errors, and then moving paper around. So one example. Our second example is with the US Air Force. This is a pilot program to support tool control and accountability. For all equipment tools that touch a plane, has to be accounted for 100%. So whether it be a screwdriver, socket, or even a rag, all of that has to be accounted at the start of a work shift and at the end of the work shift. And we're helping the Air Force to move from a legacy system on the left to more of how retail is managing their inventory on the right. So deploying mobile scanners in offline capabilities to support work in the hangar and the flight line, to deploy analytics to know what inventory is being moved the most so that you move them to the right position, such as moving them up front for easier access, to track parts, to do all sorts of different things that, again, other sectors are already ahead on this. The benefit to Joint Base Charleston is that they're able to transact and record all transactions to know analytics, and also to derive certain things like lost tools. Joint Base Charleston was able to reduce their search time for lost tools by 80%, which reduces the potential for grounding planes when tools are lost. So just two examples of our work using our framework. So in closing, we believe the future is here, specifically to think about assets, to use them, to make sure that they're ready and available when needed. However, that future is not evenly distributed, especially when it moves beyond airframes and weapon systems down to generators and hand tools. So we believe that the defense sector can benefit greatly from our approach. So with that, I will take any questions.
Perfect. Thank you so much, Tom. All right, as mentioned before, we'll do it in order of whoever raises their hand. Feel free to go right ahead. James, you're up.
Hi, that was a really great presentation. I do love asset tracking and data management. You said you had you're working with Charleston. Does that mean you're working on a broader Air Force contract, or are you looking to kind of work base by base? Have you reached out to AFWorks? Who are you working with at the Air Force level? Thank you.
Yeah, thanks, James. So we are working with AFWorks. And we have a pilot project at Charleston and Travis right now. And we do have endorsement at Charleston to move forward to a procurement. And we have also support for the project across 5 different units in the Air Force.
That's awesome. I'd like to chat with you offline. We fly 238 aircraft, about 150,000 sorties a year. So that is a lot of
Wonderful.
maintenance, and we have some folks who might be interested. I'd just like to ask you
Wonderful.
and get you guys in touch.
All right, I'll reach out. I'll give you my contact. Thank you.
Thanks, man.
Absolutely perfect. We have time for one more question. If anyone has a specific question now.
Let me just also mention that, yes, I've shared some examples of simple tools, but we're also working with the Department of Navy to support missile health maintenance as well. So it's not just dumb equipment.
Perfect. Perfect. Awesome. Awesome. Thank you so much, Tom. Make sure to leave your contact information in the chat, or give it to whoever needs it, and we're also happy to connect you offline afterwards. But that was excellent.
All right, thank you.
Perfect. Next up, we have, and it looks like there's something in the chat right now, so you should take a look. Next up, we have Cyberlander, and presenting for Cyberlander is either Lance King or Bill French, but I believe it's Lance. The floor is yours, Lance.
Thank you, Asher. Yes, it will be me. So Cyberlander is a product from Streamit. We're based here in Austin, Texas. We like to say we've got silent mobile electricity, communications, command and control, and accommodations. So you've probably seen the Tesla Cybertruck. It's made quite a stir the last year or so. Our product is integrated in that. It's actually a camper. It's available retail, and we already have more than $130 million worth of orders for it. But we thought there was a good dual use for it with the military. So imagine these being dropped out of an airplane, 3 or 4 at a time, and being deployed either in flat black or camo to hot spots around the world with a 450-mile range. The green circle would show how far you could go out and back on a charge in Ukraine. Don't know why I'm using a map of Ukraine. And the blue line is how far you could go out, but not back. So basically the way it works is in just a couple of minutes, at the push of a button, you can deploy accommodations, and a couple of minutes later, you can all be buttoned up and you can be off down the road. So imagine some of these for command control communications with the Starlink satellite uplink, controlling from inside here. You can monitor the drones that are being deployed. This is the Switchblade drone. You could have 24 or more of these in another Cybertruck and have them controlled from the Cybertruck with the Cyberlander in it. These could quickly go out and cover a vast area very quickly and be very mobile. So it's a great standoff way. And So this combination gives a tremendous range, 450 plus miles of range on a charge, 0 to 60 in 3.5 seconds or less, even with the Cyberlander in it. Top speed of 125 miles an hour or better. It can be recharged at any 110 or 220 volt or 240 volt outlet, like it's common in Europe. Can power dozens of drones, support 2 people for a week or more with water, food, and shelter. Can hold 4 to 5 personnel inside. Technically 6 is what Tesla says, but it gets a little tight that way. And then you've got excellent communications, command and control platform. So this doesn't really compete with the Bradley fighting vehicle, but by comparison, for the cost of 1 Bradley, you could get 10 Cybertrucks with Cyberlanders. Instead of supporting 9 troops plus 2 crew, you could support up to 50 troops. Max speed of 100 miles an hour compared to 35, and range of 450 compared to 250 miles. The fuel is electricity instead of diesel, so it's silent instead of noisy. It can be recharged just about anywhere. You don't have to have a diesel supply line as long as there's power still operating in your theater. And it accommodates up to 2 people. It also includes Starlink, satellite communications, and many other features that, of course, a Bradley fighting vehicle doesn't have. So it's much like the Sherman tank philosophy in World War II, where it was not the most armored tank out there, but we could produce so many of them so quickly that it gave us an advantage. And I think that's still a viable strategy even today. So strategic advantages. You can launch and control drones from it and power them, which is an issue, is having mobile power. It's silent, fast, and affordable standoff. You've got range to cover vast areas very quickly. You can power drones, radios, and mobile devices for many, many soldiers. You've got mobile communications, command and control, and self-contained accommodations that can be deployed or stowed in just a couple of minutes automatically. So it's a potentially new capability that can really change the way you operate, and could even potentially avoid some conflicts by virtue of having that capability. So we just thought we would share that as a potential dual use.
Perfect. Perfect. Thank you so much, Lance. All right, it looks like Mike already has a question. Mike, go ahead.
Hey, Lance, welcome to Austin. I like it.
Thanks, Mike. Be here.
I'm sure you're enjoying how cold it is right now, so just try to bundle up. So my question is, of the pre-orders, how much of that is from the military, and are there any from a consumer use?
So it's all consumer currently.
Interesting.
This is kind of our debut for the military. It has taken off like wildfire. We actually stopped promoting it about 9 months ago, and we have sales virtually every day anyway. It has taken on a life of its own. It's captured people's imaginations because a traditional RV is not aerodynamic, and that dramatically affects your range. But because this collapses within the bed or vault, as Tesla likes to call it, there's no additional aerodynamic drag. And so the range reduction is only 5% due to the additional weight. So you have almost the full range. And so that's really captured people's imaginations. They don't see it as a camper. They see it as the first lifestyle vehicle, the thing that lets them go to the park and have a bathroom for the kids, go to the beach and be able to shower before they go out to dinner, go up the canyon and go for a run and shower before you return home, things like that. So it's really taken off. And
outstanding. Is your email just lance@cyberlander.com?
It is.
All right, I'll reach out.
I'll reach out for sure. Okay, thank you.
You bet.
Lance, I just have to make a comment that Franz von Holzhausen's father is my next door neighbor.
Well, I should come visit you then. I'd actually love to get his feedback on it. I had an architect this week call me and she said, I've watched for a year, and she said, I've been fascinated by it. And she said, for a year, I've been trying to think of how I could improve on it. And I finally gave up. And so I'm ordering one today. And I thought that was flattering. So I'd love to get Franz's feedback.
Please connect with me on this. We have some, as I mentioned, some companies that are interested in deploying stuff out of aircraft. And maybe there's some collaborations we can set up.
Okay, will do. Thank you, Ted.
We do have time for one more question if anyone has. Otherwise, we will continue moving forward. Warner, go right ahead.
Hey, how you doing? So I'm sorry I jumped in back late, a lot of reception. I'm on my way home from agile flying military exercise actually, and we're thinking about things like this. So are you looking to partner as a Sbir unit with a military team? Do you not have that capability yet? Is that what you're looking for, or are you looking for something else?
That's correct. So we're completely open to how to engage. Currently, we have volunteered some of our future product to work with the veterans group that's based here in Texas. But other than that, we don't have any real ties to the military yet.
Too easy. Okay. Drones and Starlink is something we're already working on as our mobile team goes around doing disaster response and humanitarian support. So I'll try to reach out to you. Thank you.
Great. Thank you, Warner.
Perfect, Lance. It looks like you have a lot of people who want your email. So go ahead and put that in the chat.
Yeah, let me put that in.
Yeah, put that in the chat. And yeah, thank you so much for the presentation. So next up, we have Profian. And I know a few of the panelists mentioned that they were interested in some cyber tech. So get ready. Hold on to fasten your seatbelts. Let's put it that way. Presenting is going to be Mike. The floor is yours when you're ready to go.
Thank you very much indeed. So my colleague Jen is going to be sharing the screen. We have some interesting challenges with slides otherwise. There we go. Hopefully you can now see some slides. Excellent. Hi. So my name is Mike Basal. I am CEO and co-founder of Profian, a confidential computing company. You may not have heard of confidential computing. It's part of the privacy enhancing technologies sector and allows generalized compute. Let me talk a little bit more about what this is about. So let's go to our next slide. So the basis of what we're presenting today is that not all clouds are good. Not all systems can be trusted. So basically, unless the machine, the computer, the system you're running is entirely under your control, the hardware and the software, you cannot trust it, which means that you've got all sorts of problems if you want to deploy into certain scenarios. It's not just the cloud. It goes a lot further than that. So let's pop to our next slide. So what sort of use cases are there? Well, the very first set of use cases are your standard cloud deployments. There's a whole bunch of applications, a whole bunch of data that you cannot deploy to the cloud at the moment if you care about the sensitivity, the confidentiality, the integrity of your data or your applications. That's true for banking, it's true for healthcare, it's certainly true for defense and the military. But also the same goes for on-prem. It may be that you're storing data, managing data, processing data, which has higher sensitivity than maybe all of your sysadmins are cleared for instance, and that could be a problem. But it goes beyond that. What about embassies or remote battlefield forward stations? There are a number of industrial security use cases that we're talking to some large folks about. But also, I was speaking to someone from the UK defense industries fairly recently, and he was saying, there are certainly use cases where they are deploying their applications onto infrastructure which is managed by, let's say, other NATO countries. Now, of course, we're all friends, you're going very well. That doesn't necessarily mean that we're happy to share all the data to everyone in those. And when it comes down to it, if they have control over those systems, they can currently look at them. There's also use cases for UAVs, semi-autonomous assets, and we're also even speaking to some folks around space. So what does Profian provide? It provides hardware-based assurance. So that's based in the chips. These are standard chips, standard server chips. And we're assuring not only the integrity and confidentiality of your data, but also of the apps themselves. In many use cases, we know that the apps are as important as the data. It may be that everyone can see what data is going in. It may be, geodata, it might be market data, it could be and any type of data, intelligence data, which might be available to all. But the actual processing management of that is something that needs to be controlled. So let's go to the next slide. So let's look on the right. We have a standard system. The sort of red dotted is just a standard system with a couple of workloads on it. And the problem is that in the bottom bit is your host operating system, will hypervisor, your container management, administrators, all of those things. And the way that computing works at the moment, anyone who has privilege or control over that, whether it's compromised, malicious, or it's just intentional, can look inside and change those workloads. Next slide. These technologies that we're using are from people like AMD and Intel, and ARM is producing some to come, and IBM. And they're called trusted execution environments. They're based in the CPUs and they encrypt the data. The data is encrypted in use, not just at rest in storage, not just in transit on the network, but in use. So next slide. And what this allows you to do is to have cryptographic hardware-based assurance that these other workloads can't look in and a compromised host can't look in or change either. And this is not our technology. We're using these technologies from the chip manufacturers already in the chips, but making it easy to use, easy to scale, and applying it to different sectors. Next slide. So what a bit about the technology. It's based, as I mentioned, on these different platforms, and we are platform neutral. It's 100% open source. That's the way we believe that all security software should be. Well, frankly, all software, but certainly all security software. It's written in Rust. For those of you who are geeky like me, it provides you some lots of very nice properties there. We're also language neutral in that you can be writing in pretty much any language you want. C, C++, Go, Rust, Ruby, Python, even COBOL, and creating an application which will run across all of these different environments. We have a very small trusted compute base. This is really, really important in terms of being able to audit it, to know what you're looking at, to know that what you're running is what you think you should be running. And it's available, can be used either on a standard online or in an air-gapped deployment as well. If you're interested to know a little bit more about the basis of the technology, you can look at the narcs.dev website. We're pleased to have you there, and please get involved. Next slide. Just a little bit about us. We were founded about a year ago now, $5 million seed from some European and UK investors, VCs that is, and some angels, including Olivia Pamel from Datadog, a couple of folks in the WebAssembly space, and Jim Whitehurst, who used to be chair and CEO of Red Hat and then was president of IBM. Although we were only founded a year ago, it's based on 4 years of design and development, which was spun out of Red Hat, amicable spin out. And we are right now at the stage where we have MVP. Our initial focus is on a SaaS offering to both the finance sector, but also defense and security, which is obviously why we're here speaking to you folks. Next slide, please. What are we looking for? We would like people to be trying it out, giving it a go, doing proof of concept, moving to pilots. That is the basis, of course, of the commercial offering. Also, we want people to engage with that open source project, people to get involved in the engineering, to do auditing. I talked about auditing. It's really important to us. Also to provide us with use case analysis and to do that in conjunction, not necessarily out in the open. Some of these things we need to keep quiet, obviously. In terms of investment interest, we are looking at grants, and we are preparing for a Series A in the next 6 or so months. Next slide, please.
30-second warning.
Yep. Where are we? Where we're based in North Carolina. We've got the founding team had already 45 years at Red Hat. We've got folks from Red Hat, Docker, Intel, Booz Allen Hamilton, etc. NX has over 800 GitHub stars, so we're getting very good traction in the open source world. And our last slide is questions. So if you'd like to get in touch, info@profian.com. Find me on LinkedIn. I think I'm about the only Mike Bursell, and I'd love to have any questions. Thank you very much indeed for your time.
Perfect. Thank you so much, Mike. Feel free, panelists, feel free to raise your hand and we'll get to them in order again.
So there's a question, I think, from James in the Q&A. How are you protecting the data and cloud transfers between UAV and your communications? Is that for us or is that for somebody else, James? I'm assuming that's for us. So yeah, so the answer is everything is TLS. Everything is encrypted, not just in use, but also in transit and in storage. Data encrypted through open source. What kind of encryption using? Standard TLS, but one of the things we've done is made sure that we are crypto agile. So if we need to be swapping out crypto cipher suites, we can do that as required. Technology hasn't been approved through NIST yet. NIST is taking its time, and we are working through the regulators and NIST to talk to them about this. This is stuff which is already available in Azure, in AWS, in Alibaba, in OVH, etc. And so it's out there for a while. In terms of pen tested, not specifically ours. In fact, we've got a competition going at the moment to see if people can break in. In terms of white papers, talk to me and I can help you with that. Very quick answer.
Perfect. Awesome.
Any other questions, please? It's either the perfect presentation or the worst presentation. I never know which it means when there are no questions.
It was perfectly thorough, I think, in my opinion.
Thank you.
But definitely leave your information. It looks like James wants to connect with you. So leave your information in the chat.
Of course.
Or LinkedIn link, whatever you're comfortable with. I know that some people like to have it.
I'll provide both.
Perfect. Perfect.
Thank you so much.
Yeah, thank you. That was a fantastic presentation. All right, next up, and for the last presentation of the day, we have Bebop Sensors, and presenting is Francois. For Bebop, Francois, you could share your screen whenever you're ready to go. And just for the panelists, while Francois is getting set up, you guys mentioned robotics, so here it is. We're going into the robotics. So we're covering. I think we actually covered all of the potential focus topics. Someone said dropping cars out of airplanes, which we covered. Someone said cybersecurity, which we also covered. And then the last one's robotics, which we're checking off the list now. All right, the floor is all yours, Francois.
All right, thank you. We are looking at robotics application. When you look at what's happening around robots and automatic driving cars, cameras are used a lot to kind of figure out what's happening around those devices. But we believe that there is a big piece of data that is missing, which provide the sense of touch to robots. So think about a robot grabbing objects with their hands. Think about robots moving around into a hospital, providing some care. They're going to be bumping in things, bumping in people. These kind of events cannot be detected with cameras. We have developed at Bebop something we call robot skin, which is a fabric-based material capable of sensing touches and different changes in the material. So with this very unique fabric-based sensing technology, we believe that we can enable new applications into what we call the digital health space, but also into robotic applications. And I will explain later on exactly what I mean by that. We have a pretty strong IP position, about 32 issued patents in the US and internationally. From the business point of view, we're in the process of raising a Series B for $10 million, and we are also engaged and are looking for MOU sponsors to develop some solution for the US Air Force. This picture here is our sensor, this black kind of piece of fabric, which is currently wrapped around the cylinder. When you put your hands on the sensor, we can very precisely detect where are the contact points. Each of those different points are kind of a pixel that reports back to the system the force that is applied to it. The way we do that is we take a standard non-woven fabric, go through a very unique process that attach conductive particles, those kind of white dots that you can see on the fiber. And those conductive particles make the fabric piezoresistive. The next step we do is we take the fabric, which is right here, and print some electrodes at the back of it. The electrodes can have any kind of shape and define what resolution on what shape the sensor will be able to have. The whole idea again is to have a very thin and flexible piece of fabric that you can wrap in any shape. Think about the fingers of the robots, but you can think also about the arm, the torso, anywhere that can measure the pressure, the bending, and the shear at any point of those devices. Our sensor is, you can design the electrodes behind the fabric in any kind of way, so you can have multi-point resolution. It's very thin, it's flexible, it can be wrapped around any kind of shape. One thing that makes our sensor very unique is also its dynamic range. We have a very wide range of dynamic range, up to 80 decibel, which give us the capability to measure very small force, like 5 grams, up to very larger ones like 150 kilogram. And this is a very unique kind of aspect of our solution compared to any other sensors available there. The other thing that we do very uniquely is that we are very fast and repeatable. Fast is important because when the contact point happens, you want to be able to react to it very quickly. And repeatable, of course, you want to make sure that the data that is reported by the sensor remains repeatable over time. I'm not going to spend too much time looking at what others are doing in terms of sensing capabilities, but our sensor has very unique capabilities, which I think make it a very good fit for the application we are targeting. One side of robots. So this is actually a robot's hand that we have designed. Our sensor is embedded directly into the tip of each of the fingers. These red dots here is a kind of a pressure map of each of the fingers. We only see 3 on this map, but every contact point is reported very precisely on the finger position itself. So you can imagine that when a robot tries to grab objects, interact with different things, use fine motor skills to do complex tasks, being able to sense what's happening on the tip of the finger is very critical. You cannot do that with a camera. You need to have some kind of a skin that is capable of measuring what's happening and provide the sense of touch to the robot. This is also very important for other type of tasks where the robot is in a hospital or in a home environment. The robot will bump into things, and it will be very important for the robot to understand better his environment by, again, feeling what's happening around him, but also touching him. In this picture on the right, you can see that if you use a robot with just a basic gripper with 2 things, it's a lot harder to grab objects or a large variety of objects rather than having 5 fingers and also very detailed sensing capabilities on each of the finger. So our robot skin can be implemented into any shape, fingers, torso, arms, and provide this sense of feel that is, we believe, very critical for the success of those applications. We're also focusing on something we call digital health. I'm showing you here one example. A lot of people, there are a lot of studies that have showed that the way we kind of position our body when we move things around or do some exercise has a great influence on how much fatigue and injuries we get. And being able to understand how you can understand how a user is actually positioning his body, looking at the pressure that his feet exist on the ground. So we have developed an insole capable of measuring very precisely how our feet apply pressure on the ground. And from this data, we can extract very useful information to help people receive appropriate training to understand how to position their body when they move things around. So this is another example in the category of digital health where our sensors are uniquely positioned to provide this information that can translate into very useful for anyone, warehouse workers, airmen, you name it. The team is composed of very well experienced entrepreneurs who have started and sold multiple companies. Keith McMillan is the founder of the company. He's also the inventor of the technology and working on this technology for many years. We also have a technical team with a lot of expertise in each of the areas that are critical for us: material science, software, firmware, and hardware. We have received a number of awards across a wide range of categories, from consumer electronics to more industrial kind of awards. Our technology is well recognized as one sensor capable of meeting requirements into very demanding type of applications. So as I mentioned earlier, we are looking for a sponsor for an MOU to engage with the US Air Force. That's one thing, and we could do that on one of those two applications, either robotics or digital health. I think we believe that our solution could be quite interesting to, again, help airmen to get better training to avoid fatigue and injuries. And we're also raising $10 million, since there are some in the attendance, some VCs. If there's any one of you that would be interested in learning more about our solution, we'll be very happy to send you our pitch deck. We are planning to raise this $10 million before the end of the year. And that's my presentation. I will welcome any questions from any of you.
Absolutely. Thank you, Francois. Bob, the floor is yours.
Sure, great presentation and really impressed with your technology. I've been looking at soft robotics for a long time, starting with artificial muscle, which is a spin out of SRI. I'm looking at this space for my company, Mitsubishi Chemical, but also in other areas that we're looking into for applications inside our company. So I'm curious, just where did the core invention start from? Was it at a lab or a university? I didn't catch the kind of the beginning part of the of your story.
I mean, I'm going to try to do a short version, but Keith McMillan, our founder, started to work on this technology almost 15 years ago when he was developing musical instruments, and in particular an electronic bow. And to build this product, he needed a sensor that was capable of measuring pressure very precisely on the round shape of the bow. And he spent multiple years, 5 years probably, to explore a large variety of potential solutions, and ended up being disappointed by everything that he was looking for, that he was trying, and started to work on fabrics, believing that he would be able to make a sensor using fabric. So that's how it started, and there was a lot of development work happening to get to the point where we are. A lot of IP that has been filed, but it was really coming out of Keith's brains and expertise over the many years he has been working on sensor technology.
Great,
and we'll be happy to provide more information. Of course, that's very quick.
Sure. I'm familiar with this space.
We'll be happy to set up a call and provide you more.
That's fine. We'll do that. Thank you.
Okay.
Perfect. If I wasn't mistaken, I think Warner had his hand raised.
I'll be breaking up, my friend.
Sorry about that. Can you hear me now?
Yes.
Okay. I think Warner had his hand raised at one point. Warner, did you have a question?
Yeah, my question was geared towards what sector you're trying to go after. It seems like you're leaning towards health specifically. I didn't know if you're open to other areas. I could see that application going towards the space as well, and EOD explosive coordinates disposal on some other type of applications that require sensitivity. I didn't know if you'd gone down those avenues or tell us where you want to focus.
So I couldn't hear very well your question, but I think other applications, I mean, we are very pragmatic, and if there is a good business case, we'll definitely be interested in looking at other applications. One of the key drivers for us is to make sure that we work on applications where we think that our solution is very unique and provide something that other sensors don't. So the answer is, yeah, over the years, we have worked on different things, and we'll be happy to kind of discuss with you to figure out if in fact our sensor could be a good fit for whatever application you have in mind. And we could certainly set up a call to review what your idea is, and try to just validate and qualify that in fact our solution is a good fit for you.
All right, thank you, appreciate it.
Perfect. Thank you, Warner, and thank you, Francois. Francois, it looks like there's a few more people in the chat. Omar Youssef seems to be interested in connecting with you. Oop, I accidentally turned my video off. It looks like he's interested in connecting with you as well. Definitely keep an eye on the chat as we're winding down. If there's no more questions for Bebop, it was a pleasure having all of you join us today. The Aerospace and Defense session has been, day one, a great successful event. Thanks to everyone here. And we appreciate your involvement, and thank you so much. And make sure, if you have the time, stay tuned for tomorrow. And you should see some more interesting companies in the pipe. Thank you so much, everyone.
Thank you.
All right. Thank you. Bye.
Absolutely.
Thank you.
Thanks for your time, everyone.
Absolutely. Thank you for joining. Thanks, Lance. Have a good one. Oh, one last thing for all of the last people on the call. Feel free to reach out to Samuel if you have if you want to connect with any of the companies. We're happy to make any introductions that we can. Again, we want to bring more deep tech to market. That's the thesis. So we're always happy to connect you. The one place we won't necessarily connect you, if you are soliciting services that aren't necessarily super relevant, we might not connect you. So don't be offended if that happens. But everyone else, more than welcome. If you wanna connect. Yeah, thank you so much, everyone. We're wrapping up for today. And actually, I'll keep it open a little bit more, Francois, just in case you need to, take down anything, because it looks like there were a few people in the chat. And then again, tomorrow's event starts at 1 p.m. Eastern time, and it should end at around the same time. Yeah, and there's a really good lineup for that event as well. We're really happy. This is the first time we're doing a 2-day event. So it's great. The demand has really risen, and there's really a lot of interest. Thank God.
Good job.
Yeah, thank you, Howard. All righty.
Have a great day, man.
Yeah, you too. Thank you for joining. It was a great having you.
I'm not completely. I'm a little bit confused with all the action on the chat. So I don't know if you have a way to kind of guide me and let me know who was interested in learning more. That would be great.
Brian, you grabbed it, right? Or I could download it. Both are fine. All right.
Very good. Thank you, guys.
Absolutely. It was a pleasure having you.
Have a nice evening.
Have a good one.
Bye.